To determine the appropriate conductor size for a 100 amp residential electrical service, we need to consider the ampacity of the conductors and the applicable electrical codes. In residential applications, both copper and aluminum conductors are commonly used. For a 100 amp service, the minimum conductor size for copper is number 4 American wire gauge, often abbreviated as AWG, while for aluminum, it's number 2 AWG. These sizes are based on the ampacity ratings found in the National Electrical Code, or NEC, specifically Table 310.15, B16, which provides ampacities for conductors rated 0 to 2000 volts. It is crucial to consult the most recent edition of the NEC as these codes are updated periodically. Ampacity refers to the current carrying capacity of a conductor, expressed in amps. The selected conductor must have an ampacity equal to or greater than the maximum load it will carry. In this case, the load is 100 amps. It is also important to account for any voltage drop. Voltage drop occurs when the voltage at the load end of the conductor is less than the voltage at the source due to the resistance of the conductor. Excessive voltage drop can cause appliances to function improperly or even damage them. The NEC recommends limiting voltage drop to no more than 3% for branch circuits and 5% for feeders. To calculate voltage drop, you will need to know the length of the conductor, the current it will carry, and the conductor's resistance. Online voltage drop calculators are available. There are several factors to consider when selecting conductors. Firstly, the type of insulation affects the ampacity. Common insulation types include THHN, THHW, and XHHW. Each insulation type has a different temperature rating, which affects the amount of current the conductor can safely carry. Secondly, the ambient temperature affects the ampacity. The higher the ambient temperature, the lower the ampacity. Thirdly, the number of conductors in a raceway or cable affects the ampacity. When multiple current-carrying conductors are installed in close proximity, the heat generated by each conductor can raise the temperature of the other conductors, reducing their ampacity. The NEC provides adjustment factors for this situation. In addition to ampacity and voltage drop, it is also important to consider the mechanical strength of the conductor. The conductor must be strong enough to withstand the stresses of installation and operation. Copper conductors are generally stronger than aluminum conductors of the same size. Aluminum conductors are lighter and less expensive than copper conductors, but they also have a higher resistance. When using aluminum conductors, it is important to use connectors that are specifically designed for aluminum. These connectors are typically made of aluminum or have an aluminum plating. It is also important to apply an antioxidant compound to the aluminum conductor before connecting it to the connector. This will help to prevent corrosion. Installation practices are critical for ensuring the safe and reliable operation of the electrical system. Firstly, all electrical work must be performed by qualified personnel who are familiar with the NEC and local electrical codes. Secondly, conductors must be properly supported and protected from physical damage. Thirdly, connections must be made properly and tightened to the correct torque. Fourthly, the electrical system must be properly grounded to protect against electrical shock. Grounding provides a low resistance path for fault current to flow back to the source, causing the circuit breaker or fuse to trip and to energize the circuit. The grounding system consists of a grounding electrode conductor, and an equipment grounding conductor. The grounding electrode is typically a ground rod, a metal water pipe, or a concrete encased electrode. The grounding electrode conductor connects the grounding electrode to the neutral busbar in the service panel. The equipment grounding conductor connects the metal enclosures of electrical equipment to the grounding system. The size of the grounding electrode conductor is determined by the size of the service entrance conductors and is specified in the NEC Table 250.66. The size of the equipment grounding conductor is determined by the rating of the overcurrent protective device in the circuit and is specified in the NEC Table 250.122. The service panel is the main distribution point for electricity in a building. It contains the main circuit breaker, which protects the entire electrical system from overloads and short circuits. It also contains the branch circuit breakers, which protect individual circuits. The service panel must be properly sized to accommodate the load of the building. The size of the service panel is determined by the calculated load of the building and is specified in the NEC Article 220. The calculated load is the sum of all the loads in the building, including lighting, appliances, and heating and cooling equipment. The NEC provides methods for calculating the load of a building, taking into account the diversity of the loads. Diversity refers to the fact that not all of the loads in a building will be operating at the same time. For example, the lighting load will be lower during the day than at night, and the heating load will be lower during the summer than during the winter. The NEC allows for demand factors to be applied to certain loads to account for diversity. A demand factor is a percentage that is multiplied by the load to reduce the calculated load. For example, the NEC allows for a demand factor of 75% to be applied to the lighting load in a dwelling unit. In summary, selecting the proper conductor size for a 100 amp residential service requires careful consideration of ampacity, voltage drop, insulation type, ambient temperature, number of conductors in a raceway, mechanical strength, and applicable electrical codes. Following proper installation practices is essential for ensuring the safe and reliable operation of the electrical system. Consulting with a qualified electrician is recommended to ensure that the electrical system is installed in accordance with all applicable codes and regulations. Using copper number 4 AWG or aluminum number 2 AWG meets the minimum requirements. Remember to always check the NEC for the most up-to-date requirements.